Hello everyone, and I'd like to do a quick video on fatty acids. So fatty acids are a hydrocarbon chain with carbons and hydrogens. Okay, so they have an acid group at the end of one side. As you can see here, there's this acid or carboxyl group, C double bond O and then OH. Okay, so this C double bond OH, and then the rest is just an R group, which is a hydrocarbon skeleton made of carbon and hydrogen. Fatty acids can be saturated. An example I gave is palmitic acid. So here's palmitic acid, and you can see it's 16 carbons. So it's made up of a lot of carbons, as you can see here. 16 carbons. I couldn't even fit it all on the screen here. But essentially, they have this carboxyl group on one end, and then 16 carbons. And palmitic acid is a saturated fatty acid, which means there's no double bonds. There's the maximum number of hydrogens and only single bonds. So palmitic acid is a 16 carbon saturated fatty acid. Okay, and that means that these molecules pack very close to one another. Okay, so these molecules pack close and stack over each other, and their solids are room temperature. Think of animal fats like butter, for example, right? Like butter and animal fats, they are rigid. Okay, so that's an example of saturated fatty acid. Now, we also have unsaturated fatty acid. So let me move this down here. So unsaturated fatty acids have double bonds. An example is oleic acid, as I put it down here. So if they have just one double bond, like in oleic acid, they're called monounsaturated fat. Mono for one. And you can see this molecule, oleic acid, right here. And there's also linoleic acid, which I drew right here at the bottom. And linoleic acid has two double bonds. So if a molecule has more than one double bond or multiple double bonds, we call it a polyunsaturated fatty acid. And linoleic acid is a polyunsaturated fatty acid. It's also known as an omega-6 fatty acid. We will look at the omega convention later. But unsaturated fatty acids have double bond. And these double bonds give a kink to the molecule or a bend to the molecule, as you can see here. And this gives membrane fluidity. So they are liquids at room temperature. Think of olive oil, right? These are liquids at room temperature. These double bonds give a kink to the molecule. Now notice how in both oleic acid and linoleic acid, the double bond is the hydrogens are on the same side of the double bond. Okay? So this makes it cis, C-I-S. So when the hydrogens are on the same side of a double bond, this makes it a cis unsaturated fatty acid. All natural fats have hydrogens on the same side of a double bond, making them cis. So oleic acid and linoleic acid are, natural fatty acids. They're cis fatty acids. If the hydrogen was actually on the opposite side of the double bond, that will make it a trans fatty acid. And these are found in like partial dehydrogenation or in some meats. Now, trans fats raise your risk of coronary heart disease, so they should be eaten in moderation or even better avoided completely. So trans fatty acids have these H groups on the opposite side of a double bond, whereas in cis, like in oleic and linoleic, they're found on the same side. In both cases, they're unsaturated, but in this case, they're cis, and if the H's were on the opposite side, they would have been trans unsaturated fatty acids. Okay? Now let's look at the naming convention. So let me just bring this up here. Let's look at the naming convention. So you can have either the delta method, which specifies the number of carbons. In this case, this is an 18 carbon fatty acid. the number of double bonds. In this case, there are 4 double bonds, and their locations. In this case, you have a double bond on the 6th carbon, on the 9th carbon, on the 12th carbon, and on the 15th carbon. And the key thing about the delta method is that it counts from the carboxyl group. So this carboxyl carbon is carbon number 1, and then you count from there. So 1, 2, 3, 4, 5, 6. So that's why the first carbon, the first double bond is on carbon number 6. Okay? The omega convention system specifies, again, the number of carbons. So this is an 18 carbon molecule. The number of double bonds, 4. So this is the same thing. And then omega 3. So this 3 indicates that the carbon that's closest to the methyl end, okay, is 3 carbons away. So it specifies the carbon that's closest, the double bond that's closest to the methyl group. In this case, it's 3 carbons away from the methyl end. So we call it an omega-3 fatty acid. So this is an omega-3 fatty acid because the double bond is 3 carbons away from the methyl end. If this would have been an omega-6, that would indicate that the double bond is 6 carbons away from the methyl end. So this omega-3 refers to this double bond, which is 3 carbons away, or on carbon 3, right, from the methyl end. If you were to start naming carbon 1 as this methyl carbon, okay? And yeah, this is an omega-3 fatty acid, which is a omega-3 fatty acids. Other types include EPA, DHA, and ALA, and these are healthy fatty acids, right? For example, DHA for the brain, EPA for the heart, right? And you can get them from eating fish, for example, or vegetables as an ALA. But these are omega-3, so that's what we refer to this naming convention, right? We start counting from the methyl end. Whereas in the delta convention system, we start counting from the carboxyl end, and we specify, the carbons from the double bonds from the carboxyl group. Whereas here, we count from the methyl group. Now, I want to just go back, and look at what we had before in linoleic acid. And if you can see here, linoleic acid is actually an omega-6 fatty acid. So in this case, this indicates that the double bond is 6 carbons from the methyl end, or is on carbon 6 from the methyl end, right? 1, 2, 3, 4, 5, 6. So the carbon the double bond that's closest to the methyl group is on carbon number 6. So this is what this is referring to here. And the 18 refers to the fact that linoleic acid is an 18 carbon molecule. 2 refers to the fact that there are 2 double bonds, each giving a kink to the molecule, right? There's 2 kinks, 1 kink per double bond. And the omega-6 refers to the fact that the double bond is on carbon 6 from the methyl group. If you were to say that carbon 1 is located on the methyl end, okay? So linoleic acid is a omega-6 fatty acid, whereas this molecule here is an omega-3 fatty acid. And other examples of omega-3 are DHA, ALA, EPA, referring to the fact that the double bond that's from the methyl group is 3 carbons away, right? It refers to the fact that the double bond is on carbon number 3 from the methyl end. So I hope you found this video helpful. Again, we have saturated fatty acid with the maximum number of hydrogen atoms, only single bonds, no double bonds, and unsaturated fatty acid with double bonds. They can either be monounsaturated, one double bond, or polyunsaturated, many double bonds. Naturally derived fatty acids are cis, meaning the H's are on the same side of the double bond. And then there are naming conventions. You can either count from the carboxyl group in the delta method or from the methyl group in the omega method. Hope you found this video helpful.